So Farhan's question is that he wanted to discuss the difference between a free action and an effective action, right?
Yes, sir.
Okay, so so before we understand free action, we have to understand what a fixed point is. Okay, so if P, so we have some manifold, first of all, or we have some space. It doesn't have to be a manifold. We have some space M on which a group G acts. So if you want to think of some manifold, you can think of S2. If you want to think of some group, you can think of SO3 in your mind, okay? So, okay, let's not go there yet because we first want to, define things in general. We'll come to an example. Okay, now so this is the action, and G is a group element, and it's acting on some point P on the manifold. So P is some point on the manifold, and G is some group, right? So if there exists some point, it can be just one point. If there exists a point P such that the action of some group element on that point P gives you back that point, for some group element G, which is not equals to E, then we say P is a fixed point. Okay? Do you understand what a fixed point is, Farhan? Yeah.
Yes, sir.
So the easiest example is that we have a sphere and, we spin it around its axis. Then this point is a fixed point. This point is also a fixed point, right? So the sphere under rotation has some fixed points. So if I take SO3 as a group, it has in it some SO2, which is the group of rotation around the z-axis. All these elements leave the North Pole and the South Pole fixed. Okay.
So does the fixed point thing work on groups without manifold, or just, manifold has to be a compulsory thing?
There you can define those fixed points for other things too. Yeah. For non-Lie groups. Yeah. You can. You just, for example, you can take a discrete shape, right? So for example, you can suppose you take a platonic solid, right? So you have some platonic solid. So it's some three-dimensional shape, right? And there's going to be some, symmetry axes that's going through, say, one of the vertices, right? So, and now instead of the rotation being some continuous group, it'll be some discrete group, right? But, the axes, the point, the vertex that goes through the axes around which you rotate, that point is not gonna, that point will be fixed, right?
Yes, sir.
So that's another example of a fixed point under a discrete group action. Of course, this discrete group is a subgroup of SO3, but it's a discrete group nonetheless. Okay?
Yes, sir.
Okay, so that's a fixed point. So if your group action does not have a fixed point, then the action is free. Okay, so the action of SO3 on S3 is not free, but the action of SO2 on S1 is free. Right?
Like rotating a circle, so no point is fixed.
Exactly. Okay.
Yes, sir.
So that's free action. Now, what is effective? It's very hard to come up with examples of effective, non-effective actions. So an effective action is if the action of a group element on the manifold is fixed, but for all the points of the manifold. You know, where the group element is not the identity. If that is the case, hang on. I think that's the definition, right? Let me just check. Okay.
I think in the lecture you said G is equal to E, as far as I remember.
Yeah, exactly. That was the problem. You're right. So yeah, if this is the case, no, that's trivially true, right? That's going to be trivially true. Just 1 second. Let me just here. Yeah, you're right. Yeah. Sorry, Farhan. So yeah. So the definition of an effective action is that if for all P on a manifold, the only group element G that leaves it fixed is E, then that effective action is, then that action is effective. Okay. So if a group action is effective if for all P in M, the only group element that satisfy G acting on P is equal to P is E. Okay, so now the question is the group action of SO3 on S2 effective or not?
Is it like only one element, only identity will keep the point fixed and every other element will change the point? Is that the case?
And yeah, and it has to be for all the points. So it is, yeah, so it is effective, right?
Yes, sir.
For all the points, I mean, there are some points like the North Pole and the South Pole, which are fixed under action of some elements, but those, you know, it's that those elements do not leave the other points fixed, right? Right. So, for example, you might say, okay, the North Pole is left fixed under some SO2, but that SO2 does not leave these points fixed, right? So it's only E that leaves everything invariant. Okay, so it is effective.
So another thing you mentioned that every free action is effective action, but every effective action is not free action. Could you please explain that? Or
every
I mean
effective action.
The sequence, I think, is I can remember, but something is like
every free action is effective. Did I say? Sorry, what did I say? Every.
If there is a bigger set, the outer shell would be effective and inner circle would be free. I drew that diagram, like free is inside and like integer number.
Yeah. So I mean, so here we see an example where it is an effective action, but it's not free. Okay.
Yes, sir.
But if it's free, then there is no fixed point, right?
Yes, sir.
So if there is no fixed point, the only element that will leave all the elements invariant is the identity, right?
Yes, sir.
So if it's free, then it's effective trivially, right?
Oh, I got it. I think you said the opposite on the lecture, but I'm not sure. I have to check.
I may have, you know, I may have. These are very subtle concepts, right? So, you know, I may have, yeah. I'm sorry if I did.
Got it, sir.
Yeah.
Understood.
Okay, can we now discuss an example which is not effective?
Sure, sir.
So if I consider the action of SO3 on a S2 of radius 0, that is a point, then it is a not effective action, right? Because all the points, it's kind of a trivial, but you know, it's an example of an action that is not effective. Because all the elements of SO3, not just identity, leave all the points of the manifold invariant. I could not come up with a better example. I looked around, but I could not. I'm sure there is. Okay, so next question. Indrani, do you have any questions? Okay, Proma, do you have any questions?
No, sir.
Okay, Shitima?
Just a small point. So you mentioned this, the term skew symmetric before.
Yeah.
Does that just mean the anti-symmetric
Yeah, it's antisymmetric. Skew symmetric is, I think, some old mathematical term for antisymmetric. Yeah.
Okay.
So yeah, that's it. It's a kind of an archaic word. Yeah. Okay, so Yashan,
No, sir.
Nahi.
Outside the topic, sir, have we fixed the time for the assignment discussion?
Anytime, like I can do tomorrow evening. I think so. Let me check my calendar for tomorrow evening. Okay, just 1 second, then I can check my time. So calendar. Okay, so I can do the same time tomorrow evening. Is that okay?
Works for me tomorrow evening.
Okay, so from maybe, you know, because maybe can we do it from 6:50, because I think the time is shifting, right?
Yeah, that
Yes.
would be nice, sir.
Yeah, so let's do it from 6:50, right? I can even do it from 7 to 8 if that's better.
Yeah, so 7 to 8 is better.
What about
Yes,
other people? Okay,
that's
so assignment discussion tomorrow at 7 to 8, okay? I'll post that on Slack.